Okay, so this is a relay logic. We've got a problem here in front of us. We're going to have a start button, a stop button that is green and red. We're going to have a red power on light. The start button is going to be normally open. The stop button is normally closed. We'll have a green light when the system is on. The green light turns on. And when the system is on, the selector switch will be able to turn on and off a yellow light. So the first thing that needs to happen with a control system in relay logic is that we have to have the rungs. Pardon me, those are the rails. So the rail, we're going to have voltage and then common. It can be AC voltage and neutral, depends on what voltage we're running. That is going to be dependent upon the outputs that we drive. So we have a relay that we'll have to drive, or lamps that we have to drive, motors that we have to drive. In this case, we're going to just assume they're all the same voltage. And if that's so, we're just going to have a voltage and a common. We need to create a start circuit. We want a master control relay that controls everything. In this case, we'll have a control relay that's driven by the start-stop buttons, normally open and normally close. We need to name that relay so that we know what it's called. I'm going to use the letter A just because. There's no reason, rhyme or reason. It's just a simple letter. And that is an output. Outputs go on the far right. We read left to right. We do inputs to outputs left to right. Voltage is here, so current flows across the relay that way. The first thing we need to do, though, is we need to have a start button because that's going to be our start. It says it's normally open. And a normally open push button looks like this. Okay, that is our start. And we have a stop button. Now, as this is drawn, if we were to wire this up, I push this button, it activates. This allows current to flow through, and that coil gets turned on. That is just a coil, that's a relay coil, gets turned on. And that being said, it could run. However, once I release this button, it'll spring back and not run any longer. We need to use a seal, okay? We talked about this in lecture, but we need to add that seal in contact. This relay is A, and it's contact number 1. So now I push this button. This allows current to flow. This coil gets energized. This open contact closes. Now I can release this start button, and the current will now flow and maintain that coil. All right. That is rung 1, rung 2. And over here, there's a normally open contact on rung 2 that controls. All right, so we are done with start, stop. The next part of our series here is that whenever power is on, the red light is on. There is no logic to that. It just turns on when there's power. The red light is turned on as soon as there's voltage here. Voltage allows the current to flow, turns on the light, and common comes out. That one is done. System on. That means our relay is on. So this is basically A active. So a normally open contact, A-2, will drive the green light. This is rung 3, rung 4, 4. So this coil controls an open contact on rung 2 and an open contact on rung 4. We've got a green light when the system is on. A selector switch controls the yellow light when the system is on. There's 2 ways we can do this. We can add an entire new rung, call this A-3, put a comma on a 5 there, put in our selector switch, put our selector switch right here, and turn on a yellow light. But let's say we don't have a third contact. We could actually go ahead and do that. Both are totally correct. Then this has to get removed. So when that contact is true, this light turns on, and then this yellow light is controlled there. So these are a couple different ways of skinning this cat. Hope that was useful. Thank you.